Okay, so I'm going to give a short presentation on what is federation. I will leave the slides like this. I hope everybody can see them. Otherwise, I lose screen of the meeting. So, what is federation and a data space? We always talk about data spaces and about federation, and so I thought I'd look a bit into Wikipedia. What is federation? I changed it a bit by saying it's an entity characterized by a union of partially self-governing entities under central governance. So there's self-governing and there's central governance. So that's what's called federalism. And then data spaces, if you look into definitions of data spaces, we have all types of definitions, but I took this from an EU-funded project, and not from the national data spaces, I think. So it says it's a decentralized data sharing infrastructure in data ecosystems with common capabilities. Now there's a new challenge introduced, like what is now a data ecosystem and what are these common capabilities. So we will look into these and to see, well, what is, I will forget about data ecosystem because this is what I understand. The number of stakeholders that is involved in this particular case in supply and logistics. And now my clock is also on the recording. And I will look into common capabilities. So if you look at common capabilities, this is about interfaces. So it's to support business. This is what we call the technology independent services. It's the compliance to regulations. So it's business to government and maybe government to business, depending on what type of data can be provided. And it's about safety and security, say, for instance, on the infrastructure. So it's about government to business and port decision-making, corridor management, and what have you for all types of infrastructure management situation. And this is also based on compliance to regulations, business to government. So providing dangerous goods, classifications, all this kind of stuff. And it's about, and now I put there IAA, it's about security. So what is called normally cybersecurity. So you must know with whom you are sharing the data in an open and neutral environment. So it's about identity, authentication, and authorization. So what data do you have to provide to the one that you can identify? This is all part of the trust, and it's all part of applying everything on a large scale. And I assume that Michel will go further into these. So then we have to look at the technology independent services. So these are a bit of the few. So you have the logistic services that you can publish, search, and find. You have negotiable logistic services or non-negotiable. Non-negotiable means that the only thing you can do is buy them. So you put an order and you get some planning. Negotiable is that you have a contracting phase with booking and confirmation. So if you look, for instance, at main modalities like sea and air, you sort of have non-negotiable services. So prices are sort of fixed. You know the price per container mile, per weight, so you can book or you can't book. Booking means that you temporarily put forward an order, and the order is confirming what you know, and you provide the details, and then you go into execution. Additionally, you must have capabilities for cancellation, because something may go wrong on the way. And this all relates to the semantic model. So what you provide as data depends on what you want to be shipped. For containers, you provide container details. For goods, you provide packages, types and size, weights, and so on. So this is all modeled in the semantic model that Henk will explain. Now, if you look at these services, so this business support, you can find solutions like a logistics service registry or marketplace. There are already quite a number of these marketplaces, basically for what they call spot market. So you can publish your spare capacity, and someone else could book it. There are various booking and ordering platforms that already exist for different modalities. And what we see is all types of visibility or track and trace applications that pop up, but they all have different, they all use different technology, and they all have different interfaces, so it's not possible yet to integrate these solutions. And we've positioned the metadata search engine on top of this as visibility to authorities. So these are examples of applications you can see. Now, if you look into, I don't think it's animated, but if you look, for instance, on supply chain visibility, so this is maybe a bit of a complex figure. You have, in this example, 2 customers and 1 service provider. First, they have to agree on the order, that the order exists. So that's put over here. So the box over here is, say, the supply chain visibility platform. So they state we have an order. So this customer and the service provider and that customer and the same service, they have an order. What happens then? And the order can link to back office data, either with the customer or already with the service provider. And that data is based on the previous phase that they had. So it's based on the ordering phase, and that's based on the booking and so on. So transport order data can be stored by the service provider, but also by the customer. But they have to agree on the link they provide. So the order exists, and once the order exists, the service provider can upload its itinerary. So what sequence is going to pick up and load and discharge the goods, and what is the sequence in which it calls upon places where these customers have said that the data or the goods will be available. And now, once you have uploaded the itinerary, you can upload events. And these events, they provide the information of what happened. So once you publish an event, based on data on the order that you agreed on, these events are distributed to the customers. So for instance, if the carrier has picked up goods for this customer and says, I now have loaded these goods, this event will only be distributed to that customer. If he also at the same location picks up goods for the other customer or drops off, so you could say he picks up goods for 2 customers and drops it off at the distribution center of a retailer, then the drop off is one event, and this event is distributed to both customers. At the same time, authorities may also have a view on what is going to happen and what actually happened in case of, how you say it, in case of, for instance, what we're looking at, road accidents, where trucks are involved. In these particular cases, you want to know what's in the truck. So you need to know what has been loaded and not yet discharged, and what is the sequence of the itinerary, where are we, and what has been loaded in the past. And based on that, you can get all the data and maybe the links to the back office data that you need. Now so I said this picture looks a bit of complex, but there are basically only 2 APIs. So it's the ordering API, sharing the order, and it's the event API for distributing and uploading events. The internal data structure can all be based on digital twins. So you have, for instance, as an example, you have a container and a truck and an event. These are digital twins. And they are stored like, you could say, normal table type of approaches. You have a container, a truck, and the association between them, the event. And the event contains dates and times of what has happened. Now, I put here also TradeLens as an example of such a platform. They don't state it's the order, but it's the container track they expect. And based on the container track, the events are uploaded and distributed to relevant users system. So this is basically how it could work, and we are already working on these interfaces to see how it will look like, and also on the internal data structure, where the internal data structure is reflected by the semantic model, and the link and getting access to the data also is based on the semantic model. So whatever data you retrieve, you could relate it to the semantic model to be able to consume it as an authority or as a customer, or who are you. So underlying is the semantic model. Now, if we go a bit further, you could say we have one basic rule in this, and this is a bit of a complex picture, abstract picture, I have to say. So you have organizations with their own business process in IT, and these have to behave according to these technology independent services. So if you go back here, these are the technology independent services. And what we're really saying is that they have to behave according to the specification developed and based on the semantic model. But they also have to give access to the business to provide additional data, like what I said, the itinerary and events. In case of accidents or incidents or what have you, they need to provide access. So the basic rule is really TISC compliance, and it's all based on APIs. And now if you go to TISC compliance, what does it imply? So there's a sort of requirement for a distributed data broker, which I will show how it works. You will need to find enterprises and their capabilities, so their business services. You will have to be able to retrieve their relevant part of the technology independent services. So what I did not explain yet is that they don't, each enterprise can select what part of the technology independent services it will implement. So it will, for instance, say, I only do ordering plus visibility. And the booking and contracting is always based on framework contracts. So this is what I support. The other part that's built into my systems, that's a negotiation for which I have framework contracts for 3 or 5 years or something. So I need to know what do they implement and where can I find it. So, the second point, because besides this requirement for the broker, enterprises have to implement supply chain visibility to be compliant with authorities. And this supply chain visibility can also be used in the business-to-business context. So they need to provide it to authorities, in case of accidents, in case of risk assessment or what have you. And they can use it for their own purposes with their customers. And then if they implement it, conceptually, they have to behave like this. And but if they implement them, you can always have a solution of choice, either a platform, peer-to-peer, or a distributed variant with access point or with triple stores. So the platform, peer-to-peer, and peer-to-peer two potential solutions: international data space architecture that's based on connectors, I will briefly show it, or a blockchain ledger based structure. So for instance, the platform is simple, so you have to integrate your system with the platform. This can be either on the technology independent services or the services that the platform locally provides to the members. But then the platform has to behave according to these technology independent services and has to support business to government feasibility. Now the data space is a bit the same, but then the data space consists of the data broker, connectors that are interconnected by protocols, and these connectors behave as if they provide the technology independent service. So as an organization, you know what the other one can provide based on these technology independent services. Now there's also a clearinghouse, and this clearinghouse is a sort of log and audit trail. So it stores what has been exchanged between these connectors. Now, the question we still have to answer ourselves, is this sufficient for the business to government? And who runs the broker and who runs the clearinghouse? Those are the questions. But this data space does not store any data. If you go back to my definition of data space, that this one is really different from what I gave as a definition, because that definition was based on these individual organizations. So there's a set of organizations providing with common capabilities. So it's a bit different from the intention, but this is a way of implementing it. Now, distributed ledger is a bit similar. So you have distributed data storage in different nodes, and you have on-chain code, and the on-chain code provides the technology independent services, and this one can provide business to government feasibility. So and the on-chain code makes it easy, so it's centrally developed on-chain code, and this can be easily distributed to all nodes. This is inherent to the technology that you have. If you look at the technology itself, distributed ledger, there are various technologies that you can use. Ethereum is the most well-known for Bitcoin. But Ethereum is transparent and open. So if you want to hide what you're sharing with others, you should apply cryptography on the data. That's one thing. And then you run into issues with key management. There is other technology like Hyperledger Fabric. It's open source, where the development is driven by IBM. And Hyperledger Fabric has a construct called channels. So you can implement your node as an organization, and you can create a channel technically to another node. So you can create a channel to your customers. So this is a very static structure that you have based on the technology to create channels. And this would well serve framework contract situation, because these framework contracts are stable for 3 to 5 years, and then the channel is stable for the same period. If, however, it's more agile, then you need to have other types of tools based on, for instance, distribution list. And then another technology pops up like Corda. Corda has been developed by the major financial institutions. And in Corda, you can have all the data in your own environment, your own nodes, and selectively share data with other nodes. And the network is completely meshed. So whenever you install a node, the node can be recognized by the network, and you're part of it. So these are the 3 solutions, or 4 solutions: platform, peer-to-peer with IDS and distributed ledger, and adapters based on, for instance, triple stores. Now the challenge is how can I create this type of infrastructure where, in case of a platform and a distributed variant, and this compliance, so compliance with the standardized services, I don't need to have an account with a particular platform. So, and how can I make use of the platform? Because I want to share data with my business partner. And in the peer-to-peer, how can I create a structure where someone that implements a particular component is known by the network? For instance, we look at figuring out if I can have a Corda-based distributed ledger that links to a node that's based on, for instance, the Kafka broker. And how can I get the Kafka broker known to the network? So this is a bit of the technology challenges we are looking at. And I hope to end it here. So are there questions?